Hi, welcome back to the breadboard. A few videos ago I started a series on programming the Arduino Uno or Arduino Mega, basically Arduino programming. It was featuring a board from Banggood. It was either the ATmega 328P, which is the Arduino Uno, or a ATmega 2560, which is the Arduino Mega. Now, one of the things I didn't do there was talk about some of the things that you can do with it, some of the bits and pieces that you can add onto it. So what I've done is I've grabbed a whole bunch of parts that I have available to me. This is just a small fraction of them. I wanted to try and have a bit of a range of what I have available, and just to go through them to show you some of the things that you can do with an Arduino compatible microcontroller board. And so without further ado, let's just start going right through this. I'm just going to kill my face off of the screen because I've kind of filled it up with everything else. So one sec. All right, so you can see here, huge layout of parts on here. And starting sort of, I've roughly laid them out in some sense of order for the controllers. On the right-hand side, when Arduino first came out, they had the Arduino Uno. So what I have here is one of them. Let me just go to a closer view of that one. You'll recognize this as being the genuine Arduino Uno that has been around for a long time. This one's made in Italy. It features basically the ATmega 328 controller, originally from Atmel, now from Microchip. You've got a small Atmel controller here to deal with the USB interface. You can program it from this header. The main Arduino you can program either through the USB port as the standard way of doing it, or if you've got an ATmega 328 without any bootloader in it, you can program it through this connection, which is called an ISP connection. Very simple things to do and very common, especially if you're running tight on memory allocation and things like that. And then all your GPIO plugs in these two sets of headers. You've got analog, you've got PWM outputs. These are the ones with the little squiggly lines next to them, like on port 5 and 6. And the rest of them are digital outputs. You've got a VREF and supply voltages available as well. You can typically run these on sort of like 7 to 12 volts going in here, or power them from the 5 volts of the USB adapter, or plug in supply voltages here. But you've got a very limited regulation. It's typically been linear in these earlier ones. So if you go to the higher voltages on the input and the barrel connector, you're going to generate a bit of heat in losses over there. Also, these pins don't give out a lot of current. So whilst you might be able to drive a single LED or something, or read a resistor, whether it's high or low, going to ground or V plus through a resistor, or some other very low, maybe 10 milliamps-ish, sort of to 20 milliamps maximum current. Now, just switch back to there. These boards below it, sorry, wrong view, get rid of me. These two boards below are also Arduino Uno sort of compatibles. This one is another genuine one. You can see it's a bit of a different color. I have some from Banggood and some just very generic brands that I had gotten from eBay or other sources over the years. Why do I like the Arduino Uno? Well, the chip is in a socket. If you look here, this is the Arduino Mega. The biggest difference between these two is the fact that you've got way more pins to do things. You've got more flash space and more RAM as well. The 328 has got 32K of flash. The ATmega 2560 has got 256K of flash. These are two compatible boards as well. This is an Banggood brand that they kindly sent me, and this is a no-name that I got from eBay way back. The reason I like the Uno, especially if you're a beginner, and I would recommend the Uno as a starting point, is because if you blow up the chip, and if I just zoom into one of my other ones, this is one that I was working on when I had it connected to a CNC machine, and I accidentally scraped a 24 volt line across one of the digital pins that was connected to the chip. And as you can see here, it basically let out the magic smoke and no longer works. Haven't tried to fix this yet. Hopefully all I have to do is change the ATmega 328. Because it's in a socket, I can just grab a new 328 and drop it in, and I should be up and running again, assuming I didn't break anything else. And here is, let me go back out. Bottom, I have a custom-made Arduino Uno compatible kind of board. You can't program it through the USB connection. That's only there to provide power. You can see that it's not really Uno compatible, but it does use the same controller. So if you programmed one of the boards in one of these sockets, you could take it out, drop it in here, or you can program it via the ISP socket. Now this is a board that was developed years ago by a friend of mine, Pete Scargill, over in the UK, for a little project he was working on. And if you look at the back of it, you can see there's a, get it under the right camera, whole bunch of LEDs and capacitors and various other things on the bottom. So this is a double-sided board. All the LEDs are connected to the ATmega 328 so that you can turn them on and off through code without having to have any external connections, which is really cool. But all of the I/O that's left, and obviously a lot of these are set up for low current, come out to these connectors so that you can drop in your peripherals. Like I have a DHT22 temperature and humidity sensor here. So that's the ATmegas. The next one along I've got here, this one is also ATmega 328, just happens to have a sticker on it. Great for plugging into a breadboard, for instance. That's not an ATmega, just to clarify. And then you could jump her off to other things. Now we'll show you how to do a do-it-yourself Arduino Uno, if for want of a better word, on a breadboard in another video. This one here is called an Arduini. This one actually came from a company called Solarbotics. I'll just change the view here, and you can see it's actually an ATmega 328 soldered onto the bottom of a pin header set that then has the main runtime components literally soldered on top. So this is about the smallest footprint you could probably get and still be able to plug it into a breadboard, etc. This little header here would be for programming, and you've got an LED, which would be your pin 13. You've got your reset button up here, and just your basic crystal and other components. It's got a little resonator. This is the blue component here. But functionally, it's exactly the same as an Arduino Uno when you program it. It's just not got the USB interface or anything like that. Okay, coming along the line here. So the Arduino Uno and the Arduino Mega both run at the same speed, which is 16 megahertz. These can run slower if you want to reduce power, but they are nominally, as genuine boards, running at 16 megahertz. You will find when you run a similar sketch on an Arduino Uno or on a Mega, say for instance, you would have a very tight loop toggling an input or toggling an output pin as fast as it can, so no delays. You'll find that the Mega actually will run slower than the Uno, and this is because of the overhead of the abstraction layer of where it abstracts the hardware from the programming. But the main thing is that you can take pretty much the same programs and run them on either of these, provided you're not doing ultra tight loops or you're needing the extended number of pins that are presented to you from the ATmega 2560. Coming along here, we've got a much newer board than these ones. These are all very early on from Arduino. We've got an Arduino Un and also an Arduino Industrial. These both come with a 32U4 on them. That's this chip here or here, which is actually the Arduino part of this whole board. And this is the one that connects to these interfaces. Now, the 16U4 is actually used on these Arduino Unos and the genuine ATmegas to talk to the USB, because they have a USB controller built into them as well. So all of these are using a slightly smaller version of this chip just for the USB interface. In this particular case, they're using it as the complete Arduino UN or industrial controller itself. And these two modules, there's one here and one here, these are Linux-based radios, but they basically take care of Wi-Fi communications for you, and you can just use a very simple communications protocol to talk to the radios from the Arduino Uno to do some web-based applications or transmit data to an MQTT server or to the cloud or whatever you like. Coming along here, this is the last one that's a genuine Arduino that I have out. This is one of their very latest boards. This is called an Arduino Nano 33 IoT. This one takes a massive jump. It's going from an 8-bit 16 megahertz system up to a 32-bit SAM21D8 processor. This is using an ARM Cortex M0 core on it. It runs at 48 megahertz instead of 16 megahertz. This one too has an external radio module with it. Okay, so a closer view here. What we have is the SAM-D21 processor right in the middle here. This is the big one, running at 48 megahertz. It has 256K of flash. I'll put up the specifications on the screen. We have a radio module which supports Bluetooth as well as Wi-Fi. We have up in the corner there's a little crypto chip for doing encryption of small packets of data, verifying SSL and various things like that. Over here we have an accelerometer gyro chip as well. We've got our USB connector at the end and a little bit of power supply logic and a reset button. Now the SAM-D21 has USB directly capable built into it, so the USB interface goes straight to it. Very similar to a lot of the newer Arduino boards, this is a 3.3 volt only board, not 5. The Arduino Uno, the Arduino Mega are, like all these ones, these are 5 volt logic. This is a 3.3 volt logic board. So be aware of that when you start plugging things into it. There are a lot of different new boards now from Arduino. I don't have any of them yet, but the main one I wanted to show you is this one because it had just arrived and I'm going to be doing some experiments with it. The other thing about this one is the core processor here, the SAM-D21, is the exact same processor that is in the industrial controller, the Arduino compatible industrial controller that I just published a few days ago. So you can see here we've got it in a true Arduino compatible form factor. This is the MKR form factor, by the way, as opposed to the original form factor. The Uno and the Mega have the same pin configuration for these side pins. These top ones are different, and the end one on the Mega is also adding additional functionality, but they're compatible within these 4. Same with the Yun is compatible within these 4. This one, as you can see, the shape is completely different. It has the same kind of functionality in it. And yeah, that's the Yun. So what's left on here as far as processors are concerned is these two that I have here. Now, I brought them here to show you, not because they're Arduino boards, because they're not. They're also from Microchip. Let me zoom into those so you can see closer. Okay, these are called AVR boards. As you can see, has quite a lot of I/O on it. And it kind of stops about here on the board, so ignore this side for the moment. And there is an exact equivalent of this processor in an Arduino genuine board. I just don't have that one. It has these 2 chips on them, one on each of them, and this provides a full debug capability on the processor that you're developing against, which means you can put in breakpoints and everything else. This you can buy as a separate unit if you're doing a lot of microchip development, where you would just plug it into the programming pins, etc. And in this case, though, when you buy them like this, they're included on the board, and you don't program them with the Arduino IDE. You program them with your Atmel Studio, and they allow you to do effectively a design layout of the pin usage, and then it writes all the code for you, and you can just focus on actually developing your application. But the key difference here when you program for these is you're effectively talking directly to the hardware. When you're using an Arduino Uno, Mega, the Nano 33 IoT, or any of the official Arduino boards, there is a level of abstraction that is given to you that means that you can write a program for one board and it will work on any of the other ones as long as you're using pins that are named in each of them. So if you were using, say, pin 13, that would be available on all of the Arduino Uno boards. And if you were toggling the output, it would be, in the Uno case, would be turning an LED on and off. In the Mega, it would also be turning an LED on and off. That's a quick example of all of these boards that are available to me. There are loads more from Arduino and also from other third-party companies that are making them. All of the Arduino boards are open source, and you can get the full schematics and everything else for them, which is great. The rest of this equipment that's laying around the periphery here, this is just a sample set of things that I have that you can use to develop for the Arduino. So let's just start and work our way around. Well, we'll go anti-clockwise. This is it allows you, if you run out of pinouts on something like an Arduino Uno, or you want to make wiring a little simpler and just have a few wires going from a controller up to a large display or something, you can use a chip like this to expand the I/O remotely. The next thing I have here is a 8-digit 7-segment LED display. It uses the exact same interface as what this one does. Uses a different chip which is designed specifically for driving 7-segment displays, that again allows you to control, that's a lot of segments if you think about it. 7 times 8, so 8, 8, 64. So there's effectively 64 pins being reduced down to just a simple serial interface. Up top here we've got a little keyboard matrix. It's just a flat flexible cable, and what it's got on the end of it is 4 connectors which would run down, and 5 connectors that run this way, and whenever you press a button it connects between those 2 points. That makes it very easy to interface to. You can just use 1, 2, 3, 4, 5, 9 wires and you could scan that entire keyboard. Of course, if you plugged it into something like this, then you can do the same thing with this as you were doing with this. Or you could use a dedicated microcontroller. Hey, why not? This here is 12-volt LEDs. Now you can't drive these LEDs directly from one of these. You would have to use some kind of interface. But nevertheless, these are available. What we've got here are LCD displays. This is a 16 by 2 line display. These other two are 4 line by 20 displays. And you talk to them. This one has got a serial interface plugged onto it. Yeah, this uses an I2C interface. Again, I'm not going to go into details right now. It's not the same as SPI. It's a little slower, but it only uses 2 wires. This one also has a serial interface on, and this one has a parallel set of connections, as you can see here, which would mean that if you were plugging it into something like one of these 8-bit controllers, you would have to use a lot more wires to talk to this one. This one basically reduces how many wires go to your controller. Over to the left here, we've got things like digital analog converters, analog to digital converters. These are on little header boards because they don't fit in breadboards in this format of chip. We've got a little OLED display. We've got a GPS receiver. We've got a PWM chip on a breakout board. This would plug directly into an ATmega or an Arduino Uno. We've got radio modules that would use the NRF24L01 radio chip. This is a current transducer. It will take current on here. It's completely isolated, and it uses a Hall effect sensor to measure the current, which gives you quite a lot of flexibility in how many volts and all that kind of stuff. We've got a DHT11 temperature sensor. The 22 is just wider range and more accurate than this one, which you can just use 1 wire plus power to measure temperature, humidity. We'll do a video on that at the future as well. We've got a digital potentiometer, which is basically a rotary encoder. Uses 3 pins to detect which direction you're rotating the pot in. Here we have a real pot that you would connect to an analog input on an Arduino or something to read its value. We have a opto isolator. We have another, this one uses an I2C bus, same as this, but an I2C version. And we have a e-ink 3-color display as well. You can see here, this has actually been powered off for probably at least 6 months or maybe even a year, and it still has the display on it. These e-ink displays are quite remarkable. They're very easy to drive, and you basically tell it what you want to display, and then you could remove the power to it for quite a while. You can see it's degraded a little bit here, but they retain their image for a long, long time. Coming down here, we've got an Ethernet module. These later ones, they've got Wi-Fi built in, or they've got Ethernet built in as well as Wi-Fi in the case of these. But these Arduino Megas and Arduino Unos and many others don't have any radio or Ethernet capabilities. So you can buy a module. This is based on the WIZnet W5100 Ethernet module. As is this one. This one is a genuine Arduino version. This is a third-party version. Here I've got a prototyping board. You can buy these for the Mega, you can buy them for the Uno. And what I've done here is I've put a DHT11 temperature sensor on here and a light sensor coupled with a resistor. So it just basically goes from the supply rail through the light sensor to the resistor and then to the ground rail. And you can measure the voltage with an analog in. And depending on the light level, that will go up and down as the light sensor changes its resistivity. You build on these prototype boards whatever you like. And then the last module that I'm just showing you here is one from Infineon, which is a very powerful RGB LED constant current controller. I've got quite a few of these, and they're very, very easy to control RGB LEDs and take a lot of work away from the programming because it's all done within here. It has its own microcontroller, uses switching mode technology effectively to control the constant current through some RGB LEDs. We'll do an example with that in a future video as well. So that is everything as far as what I've pulled out to show you. This is almost a half an hour now that I've been going through this. I was going to include things like Raspberry Pi stuff as well, and ESP32s, even TI boards too. But I figured that it might get a bit long if I started doing that. So I'm going to separate them into very specific brands. Now, having said that, all of the Arduino boards use the Arduino IDE for programming. If you use a Texas Instruments board, it uses an equivalent of the Arduino IDE. It's pretty much identical. It's just colored red instead of green. And so you can write your programs in the exact same way, and it abstracts the hardware from you. When you come to things like a Raspberry Pi, you can get an application that runs on a Raspberry Pi that allows you to write Arduino style code using an Arduino IDE, but it'll run with the I/O of a Raspberry Pi, which is kind of cool. ESP32s, another board. I'm not going to go into great details right here. Also, you can program them with an Arduino style programming. So, you know, it's these days they've extended the Arduino IDE to cover so much hardware. It is not just the Atmel or the microchip processors anymore, and it's not just simple 8-bit controllers, which is what these ones over here are. Other methods of programming these boards that you can use is Atmel Studio. You can use Eclipse these days, and you can use, which I like to use a lot of sometimes, is the Visual Studio Code from Microsoft with the Platform I/O extensions. This allows you to be almost platform independent, but programming in a Microsoft environment, as I said, Microsoft code. You can also use Microsoft's Visual Studio. You can use the Community Edition and also be able to program these as well. You have a choice with Arduinos whether you use the abstraction layer or whether you use direct hardware. Even using the Arduino IDE, you can go directly to the hardware, or you can use the abstraction layer. The difference is one is portable, one is not. If you go direct to the hardware, you can't take that same piece of code and move it to, say, from an Arduino Uno to an Arduino Mega and have it work. If you use the abstraction layer, where you're using commands like digital in, digital out and stuff, you can move it from A to B to C to D, and it's still going to work as long as the pins are available, not the physical pin, but the pin number that's mapped to the one you're using is available. So if you were using a pin 54, which is available on a Mega, which is not, there aren't 54 pins on the Uno, then obviously that's not going to work on an Uno. And it's not going to work on the Nano IoT either. But if you stick to pins that are common between all of them, then it's still going to work. You may get into issues where one of them is a 3.3 volt, one is a 5 volt, but outside of that, shouldn't be issues. Now, when it comes to expansion modules like these ones are specific to plug into the Mega or the Uno, and they're 5 volt boards. Some of these other ones, especially things like these up here, their voltages that they need varies greatly. Some of them will use 5 volts. Some of them will use plus and minus 12 volts. If it's, say, an analog to digital converter or something like that, it may need plus or minus 12 volts or 15 volts for the analog part of the ADC or the DAC, even though the digital side of it may happily work at 3.3 volts or 5 volts. Other chips like the GPS module is going to have a higher current load, so you're going to have to supply that separately. It probably wouldn't be able to supply it directly from the GPIO lines, possibly. This one is a PWM module. It's a 16-channel PWM, and if you put it all with all these LEDs and everything on it, you probably, again, wouldn't be able to drive it directly from the board. You'd have to have a separate supply to power all those LEDs. So just be aware when you're getting into this. Now, this is just an introduction to what kind of things you can get. Now, I'm going to close this off by just showing you a couple of kits that were kindly sent to me from Elegoo, which would be a good way to get started with if you don't have anything and you want to get into it. So this first one I've got here is it's called the Super Starter Kit Uno R3 project. So it's using an Arduino Uno R3, and if I just open this up, you can see here we've got, there's another sensor. This is a ultrasonic distance sensor. We've got potentiometers, you've got some fans with a motor, you've got LEDs, you've got resistors, stepper motors, servo motors, regular motors. You've got infrared sensors, buttons, light-dependent resistors, stepper motor controller. You've got relays, infrared receiver modules for remote controls. Here's a DHT11 module. Right? These kits, they range in price from maybe $30 odd, way up. This one uses these. They're not DuPont connectors. They're the round ones. I just did a video recently about how bad some DuPont connectors are that you can get. So be aware if you're buying additional connectors. These round ones, they're great for the connection, but they often will have a bit of plastic over the metal just from manufacturing. You might need to scrape that off. You get a little remote control. You've got prototyping board with a little bit of a breadboard there, a bunch of resistors, 4-digit 7-segment display, and you even get one of these LCD modules. This one's set up for parallel work, and that's all in this kit, which is really, really nice. So that's the Arduino Uno version. I've done a separate video on this already. I'll put a link. That's why I'm not really going too much into the details of what's in this. Great way to start. There are a few little gotchas that you have to watch out for, which is common in a lot of kits. And that is that some of the components don't fit in the breadboard very well. Typically, they are the potentiometers and the switches, the push button switches. So I'm going to do a video on how to do a simple modification, if you're okay with soldering, to increase the length of life of your board. Here is the another one from Elegoo. This is the Most Complete Starter Kit Mega 2560 board kit. Sorry. Let me just grab that's the 80 mega that Banggood do. Now, a lot of components here are very much the same as what was in the other one. A few additions you've got a RFID, so these are like the door access cards and stuff, and you even get a little sample card for reading. It's got a numeric keypad. Describe one of those before, as I was going through all the peripherals. So you've got one of these in here. You have a prototyping board that you can build a little circuit on, plug it on top of the 80 mega 2560 when you're done. You've got motor, display, jumpers, analog joystick, rotary encoder, servo, battery. The batteries don't last too long, so sound detector. So you've got a whole bunch of different things here, and then in here you've got buzzers, LEDs, white LEDs or multicolor LEDs, pots, switches, capacitors, transistors, more capacitors, and some op amps and things like that for building up your own circuits. And these kits come with a CD with a whole boatload of very good examples of how to build and code your circuits. So they'll take you through the coding, but they provide you all of the code pre-done too, so you could just load it up and have a look at it and run it if you wanted to. Oh, the other thing that's in here as well is a motion sensor. There we go. I've used these on a lot of projects before. They're really cool. So yeah, as I said, I've done a video on this kit as well, so I won't go into the details of it all right now. But this is a great way. This is like the next level up. But remember, the chip is soldered on the board. If you fry this, you're going to have to buy another one, unless you're really good at soldering and are able to desolder this and put another one on there. Most people are not that good. So, okay, that is the intro to all of this. But anyway, I think I'm going to call it that's it for now. Don't think that this is the limit of what you can plug into an Arduino and things like that. This is just a tiny sample, tiny sample of what you can get and what you can plug in. It's just, I think, a good starting point where you've got, you know, lights and displays and converters and stuff like that, right? I haven't shown you stepper motors and everything else. I think this is pretty much where people are going to start, especially with the lights and the switches and stuff like that over here. And these modules up here, the analog to digital and digital to analog's getting more advanced. This is a more advanced display to be using. And getting into the Ethernet is quite easy because you can just grab a library, drop it in, and it hides most of the work from you. So anyway, I'm starting to repeat myself, so I'm going to call it quits there.